Alright, this is not me. So we have people in Twitch now. Oh, hey. And Twitch also crashed. Okay. It is not the PC. It is my stupid router. It just occasions, not my tabs. It's my stupid router. It just goes every so often and drops my internet for like 3 or 4 minutes and then it comes back. It's really annoying. Okay. Yeah, seriously. Thanks, Spectrum. Jeez. Oh, hello. Okay, people who are on Twitch. OBS is, for some reason, does not want to show me the chat, so I'm going to have to, like, switch back and forth to look at the chat, so I apologize in advance. Oh, and I restarted, so now I can't see the previous chats. Dang it. Teams isn't letting you send messages. Oh, no. Teams does that to me sometimes, too. So, that's super annoying. Alright, so I'm just gonna put this right here so we can all still see it. Well, we could if I shared my screen. Trouble asking the phase a certain number of times greater than the other. Is that Annie? That's Annie. Okay, let me just finish this one really quickly. Can I make this full screen? There we go. That's better. So on Twitch it's not, you can't, what? Window. Okay. 15 and 16B. 15 and 16B. Do you mean when the amplitude is some multiple of the other? Or are you talking about 17? Okay, so I'll just finish this one really quick. If you hear nothing when you're directly between them means delta r equals 0. Hear nothing means delta phi equals pi, 3 pi, etc. So if our delta phi equals 2 pi over lambda delta r plus delta phi naught, if this is 0 and this is pi, then delta phi naught must be pi. So they must be out of sync. Out of sync sources. In order for you to hear nothing halfway between them, then a crest from one and a trough from the other have to be reaching at the same time, and since you're the same distance away from each of them, they must be making a crest and a trough at the same time. Okay. So 15B and 17B and C. Amplitude of one gamer's whining, the new amplitude. Okay. So new amplitude. Okay. That all comes down to this equation. Okay. Where this A is the new amplitude of the combined wave. And this amplitude is the amplitude of each of the individual waves. Right? So when cosine is 1, that means our A is 2A, right? So this is max constructive interference, which happens, well, okay, cosine of that equals 1, happens when delta phi over 2 is 0, or 2 pi, wait. This also happens when this is negative 1. Both of these give the same because we have a absolute value. That's what those are called. So this happens when delta phi over 2 is either 0 or pi or 2 pi or 3 pi, which means it happens when my phase difference is 0, 2 pi, 4 pi, 6 pi. Hey, this makes sense. This is what we said up here. Right. So where it gets interesting is when it's some weird other number. So there's kind of two ways to use this. Two ways to use. So if you are given a position, you can find delta r, you can find delta phi, and then you can you can find A. That's sort of the straightforward version. There's also, if you are given A, you can find delta phi, you can find delta r, and then you can find the position. So let's see, for 15 and so for 15b, that's like that first one. You have moved to sit directly in front of one of them. You know where that is, right? You know how far apart they are. You're 5.2 meters in front, right? So you got to draw a picture. So you have one here, they're, what was it, 2 meters apart, and then you were sitting 5.2 meters in front, and then you move over to sit here. So you have R1 is 5.2 meters, and then R2 is, I don't know, Pythagorean theorem. And then you find delta R, find delta phi, find A. For 17 is a little tricky. Gabrielle, did I answer your email about this? I honestly can't remember. I feel like I did, but it's possible that I did not. So this is a case, this is one-dimensional, so that makes it a lot easier. You're just talking about delta x, right? You don't have to worry about 2D complicated stuff. You have amplitude is 1.5 times greater than one child alone. It's not what I meant to do. This one. Okay. Okay. Sorry about that. Oh, good, I did. Okay. So I sent it to Gabrielle, but not Annie, apparently. Sorry. Yes. So for that one, A equals 1.5 little a, right? Where it's 1.5, the amplitude of the final is 1.5 times greater than one child alone, which is the little a, right? So you end up with, right, 1.5a equals 2a cosine delta phi over 2. And then you solve from there. The tricky thing for part C is that it says that it's what? Half as loud. Okay. half as loud is a tricky thing. Loudness means intensity. And intensity is proportional to the square of the amplitude. I think this is in the power and intensity like video module, I think. So that means if your I original, is a proportional. That's what this little thing is. It's not an alpha, it's like a thing. It's like a fish thing. It means proportional to, if y'all have not seen that before. Proportional to a squared. Let me make sure I'm doing this right. One screaming alone, yeah. So then you want your new one to be, it's that same proportionality. So I can say I original is equal to some constant, which I'm going to call happy face, a squared. He's got like a eye problem. He's wearing an eye patch. Or he's a pirate. So that means my new amplitude is going to be that same proportionality constant times the new amplitude squared. And I know that my I new is going to be 1/2 my I original. And with this information, you can solve for A equals something times A. And your pirate smiley faces will cancel. Proportional. Fish portional. Professional? That sounds like professional. Fish portional. Fish portional is pretty fun to say. Yeah. So I'll give you a hint. You're going to end up with a square root. How's this going? Making sense? That was graceful. Oh, ducks. Awesome. What else you got? Skylar says circuits. What kind of circuits? We've talked about several different kinds. All right. We'll do circuits and then we'll come back. I also have a PowerPoint full of conceptual questions that I think would be great to practice. So we're going to do that at some point. Yeah, so Skylar, so we've talked about what are all the different kinds of circuits that we've done. We've done resistor circuits. We've done capacitor circuits. We've done multiple batteries. We've done, what else have we done? RC circuits. We've done inductor circuits. We've done LR. We've done LC. I feel like that's most of it. Okay. Which of these do you want to talk about? The thing is, for all of these, there's certain sets of rules that you can apply. There's Ohm's law. There's our capacitor, or like equation that's not named after anybody. There's Kirchhoff's voltage law or Kirchhoff's loop law. Voltage law. Kirchhoff. I always forget how many H's it has. Kirchhoff's current law. Kirchhoff's current law. That's definitely enough H's, right? Yeah. There was a question like this, I think, on the makeup test. Did I post the key to the makeup test? I feel like I should have. Don't remember. Let me put a note. I can do that. Please note to account for of. You also weren't there. It was very sad. So basically, these rules apply to all of these types of circuits. It's just a matter of which one you are using where. Was the multiple batteries the one you specifically wanted to do? Let me see if I can pull up that makeup test. We're not going to pull up the final exam. Oh no, I didn't save it, that's why. Close, whoops. Let me turn off my screen share while I find it. No, I don't think we're doing much drawing graphs. Knowing what they are, and like, oh, I have two waves and they're in the same place, they add up. That's about it. The final is cumulative. It is slightly more of the newer stuff. So it's like a little disproportionately waves, but there is like, it's not all waves all the time. It's like maybe 30% instead of like 15%. Okay. Aha. So Skylar, is this the kind of problem that you meant? So the thing about these is it's important to remember that you can redraw. Let me see if I can open this in Adobe, because then I can write on it. Open. There we go. There it is. That's an inductor. Yeah. Okay. There we go. So you can always redraw circuits. That actually, I recommend, is almost the first, like, first step, is to sort of redraw it and think about, okay, I have battery. I'm going to put plus here. I'm going to put minus on this side because I feel like it goes up and then it splits. So it goes up and then it has two paths. It has this path. So it goes the 16 and the 8 and then the 20 and then it comes back to the battery. And then the other path, it goes the 6 and the 2 and then back to the battery. Oop. Does that circuit make more sense? It's lagging really hard today. Okay. So the key thing, what I tend to do is start at a battery. If you have more than one battery, just pick one. Oh, it's doing it again. Go away. Yeah. Started battery. Draw until splits. Right? Follow each split. And then both should come back to, all should come back to the battery. So I feel like redrawing helps a lot. Like this is a fairly simple, it's like two parallel paths and each parallel path has a set of parallel resistors in it. But it's not bad, right? So for example, this one, it says, it gives you the current in, it gives you a current in one of the resistors. So this is one where you kind of have to work backwards a little bit. So it tells you the current in this resistor is 0.5 amps. So, okay. Oh, I forgot how much it sucks to erase on a PDF. So we can find, you can do kind of the same tactic if you want, which is finding your equivalent resistance. So your equivalent resistance, you have 1/6 plus 1/2. So you have 6/4, 1.5. Okay. And then here you have 1/16 plus 1/8 inverse. So that is 16/3. And then that, you add the 20, and then you do inverse that plus the 1.5 inverse, and then inverse the whole thing. Ugh. And you get some value for your equivalent resistance. So this is 76/3. So it becomes 3/76 plus 4/6 -1. Ugh. 1.4 is my equivalent resistance. I have no idea if that's right. So you can do that if you want. But the problem you will run into here is that you don't know the battery. So my recommendation is to think about that kind of chart that we like to draw. I hate erasing on PDFs. It's the worst. So terrible. This is not what the software is designed to do. Okay. Close the note. So we have like our chart. We have 16 ohm, 8 ohm, 20 ohm, 6 ohm, 2 ohm resistors. And then for each of these, we have a delta V and an I. So the information that we have is 0.5 amps for I for the 8. So this is sort of doing the thing in reverse. Okay, I have R and I, so I can get V. This must be 4 volts across the 8 ohms. Because these two are in parallel, that must be the same, so this must be 4 volts. So 16 divided by, 4 volts divided by 16 is 0.25 amps. So I know I have 0.25 in this arm. So these two come together, so I must have 0.75 in my 20. Okay, so that means my voltage on the 20 must be 15 volts. So that means my total voltage in this branch must be 19 volts. Remember, I only count the parallel once. Whichever path I take, I go down 4. So it's only 4 down total, right? So this must be a 19 volt battery, which means it must be 19 volts across the 6 and across the 2. So I do 19 divided by 6 is 3.16, repeating, that's great, amps. And then I get 19 divided by 2 is 9.5 amps. And this is way more current in this path, but that makes sense because this is 1.5 ohms. This is at least 20. So it makes sense that we would get way more current in the really little resistor path. Making sense? All good. Let me check in on Twitch here. Okay, Twitch looks like it's doing okay. Back to OneNote. Any other questions? Same group. What happens to the resistor beside that? Okey-doke. So, do you mean the 20? Yeah. So these two are the same voltage. But you know that this is whatever the remaining voltage is, because like the battery is providing some amount, you spend some of it there, and then that's whatever's left to get back down to the ground floor. So it's not going to be the same, but you know that all of the current that goes through either of these paths is going to come back together and go through the 20. So the 20 is going to be the 0.25 plus the 0.5 gives you the 0.75 amps through the 20. And if you have that much going through the 20, then that means you have to have a 15 volt drop across it. Yeah. In order for, you can kind of think of it in order for the whole circuit to make sense. If that wasn't as big of a drop, that would mean the battery couldn't be as strong. We were given the current in the 0.5 in the 8 ohm resistor. That is the only information we were given. But once you know a single number on this chart, you can fill in the rest of it. It's just a puzzle. I'm going to pull up this PowerPoint. Maybe it's not in my downloads. There it is. Yes. Yes. After we have the battery voltage, we can do the same thing to the other side. Yeah. Because those are two parallel paths. There's this path and this path are parallel. You don't know if they have the same current. In fact, they don't. One has 0.75 and one has like 12. But you do know they have to have the same voltage because they each start at 19 and end at 0. Mm-hmm. It's going to take a while to load. Really overstressing these poor computers here. Oh, somebody's fishing in our ponds. Very strange. There have been no further dogs. I'm sorry to disappoint everyone. Here we go. Whee. Okay. Make this smaller so you can see the answers. Whoops. And there's 160 questions. So we're maybe going to skip around a bit. Because if we go through all, it's 160 slides, which means there's 80 questions. It's a lot. Okay. So I want all of you to participate and give me what you think the answers are. Let's get started. Oh my gosh. Where do you find these? Oh, there you go, Annie. I'm sorry. I forgot I put the Twitch app on my phone. Oops. Oh no, one of the channels I like is streaming right now. Okay. All right. So Annie, I'm watching the chat on my phone. So I should be able to see if you say something on Twitch. All right, 2 votes for B. Anybody else? The correct answer is B. Good job. I'm gonna skip. Quick random question based on homework. Is the beat frequency just as simple as difference? Yes. It's literally just subtract. It's very convenient for us. The mathematical reason has to do with trig identities. That you end up with cosine of phi minus phi times sine of phi plus phi. And then the sine of phi plus phi just becomes the wave itself, and the phi minus phi, everything cancels, and you end up with an amplitude envelope. I don't have time to really talk about it, but it's cool. Okay. 2 votes, 3 votes for B. Correct answer is B. Good job. That's what I love to give because it tricks people. It does say force. Yeah. Newton's third law. I forgot which one makes the line different. Their accelerations can be different if they have different masses, but their force is going to be the same. Let's see, how about 12? Ooh. Very confident. Correct answer is C. Good job. Ooh. Ugh. So on a test, you might want to skip this one and come back to it because there's a lot of words. People walking without dogs. That should be illegal. Yes. You're correct. Gauss's law says flux is charge enclosed. Does not matter where the charge is located. Good. A+ from y'all. Okie dokie. How about 24? So remember, it's metal. What's the electric field inside a metal? Oh, we're gonna change your vote? Yes, D. Correct answer is D. Ooh. Yeah. Not specifically because it's the center. Anywhere inside that metal sphere will have an electric field of 0. Because when you bring this positive charge close, you're right, it will have an electric field that PowerPoint wants to delete. So there would be a field this way, but you get polarization, a bunch of negatives over here, a bunch of positives over here. They have a field the other way. Those two fields will cancel, you get 0. Yes. No electric field in a metal object unless current is flowing. So you will get questions where it's like, oh, what is the current? You know, what is the electric field inside? Electric field inside a wire, right? And you have some current coming through and some current leaving here. So what you would do is, if you know the resistance of the wire, you can do delta V equals IR, and then that delta V is going to be the electric field times the distance, so you can find the electric field. You can also do, if you remember our good old equation Joe, that the current density is the conductivity times E. So for a metal that is in electrostatic equilibrium, E is 0. It's 0 unless current is flowing. It's a way to think about it. Which one is for external? Skylar, I don't think I understand what you're going for there. So the field due to that Q, if the neutral sphere was not present, right? If this was totally absent, it would be this one. Because there's a sphere there, you actually have to consider the fields from the polarization. So instead of the field being perfectly out like this, it goes. So I don't think any of these are correct for the actual electric field that you would see in real life. But yeah. Okay. 30. So I'm going to be petty for a minute. I made this figure for a test like 5 years ago, and I'm really entertained that my colleagues are putting it into PowerPoints as if it's like a real official figure that somebody made. I made this in Word using its like clip art. Okay. Electron, place the position, tone, release. What direction will it accelerate? C, you were correct. Electrons are balloons that go to higher potential. Awesome. Yay. Celebration. Like the little Kermit the Frog flailing emoji. Okay. Kind of the same question. There you go. I knew Skylar would find it. D and E seem to be the two choices. You were correct that it's going to move downward. It is moving. Remember that U is QV. So as it moves, it is losing potential energy. So it is gaining kinetic energy. Correct answer is E. Good job. Okay. Okay, let me turn on enable editing. That's why it keeps deleting what I'm saying or what I'm drawing. Oh no. Oops. Sorry. This is gonna take a minute. Never mind. Okay, I'm gonna pull it up on OneNote. Okay, so you have 0 and negative 50 volts, and you put a proton right here. U equals QV, so U equals 0, and U equals negative 50 electron volts. So it is losing potential energy, which means it must be gaining kinetic energy. So it can't be steady speed, it has to be increasing speed. Okay. Okay. It has to increase from 0, also true. If it were at rest, and then moved, it had to be an increase of speed. That's true. Sunglass emoji earned. How about this one? Q over R, yeah. So be careful, this is VB over VA. Which of these do you think is going to have higher potential? There we go. So it is C. Because B is over A, if it were A over B, it would be 3. So you gotta be, that's something that'll trip you up. You gotta look at it, which one's bigger. But yes, as opposed to the electric field, which would be 1/9. Good. This one. This is another one where you're like, okay, there's all this like stuff on the page. So I might like, okay, it's asking me about E and V, and then ignore the choices and look at it and say, okay, what do I know about E right here? What do I know about V right here? And then see if you can match one. Otherwise, I think it's easy to get lost in all the equals and greater thans and etc. This one's actually a lot easier than it looks. Okay. Field points to negative and away from positive. That's correct. So the correct answer is in fact D. See, I told you this is a lot easier than it looked. Once you knew the direction of the electric field, you didn't actually need to know anything about the potential. But remember that this is that potential. You have one that looks like this. That was really slow. And then you have one that looks like this. So exactly halfway is going to be where it crosses 0 to go down to negative. Does that make a little more sense, Skylar? That it has to cross 0 to go from a positive to a negative potential. And since it's symmetric, it has to cross 0 exactly halfway. Okay. D. Ooh. Think about this one. They both experience 3 volts. What do you mean by both? Sorry, my Twitch thing closed. There you go. So remember, for a battery, it's about the difference between the two ends. Correct answer is B. Don't overthink it. Yeah, it's that easy. Sometimes I feel like it would be worthwhile to put like, this is easy, don't overthink it. But I don't know, I guess, yeah, we want you to know that you're right and just be like, oh, that was an easy question, instead of being like, I must be wrong. Yeah, exactly, self-esteem exercise. Let's see. Let's skip down a bit. You said 3 volts, I know. So the issue is that you said they both experience 3 volts, which is very strange phrasing. So it would be like, well, at 1 it's the same as the positive end of the terminal, and at B it's the same as the negative end of the terminal, so it must be 3 volts across the battery and 3 volts across the gap. But I wasn't sure what you meant by both. That's where I got a little confused. I'm going to say B. I'm going to say B. Oh no. Okay, remember this is, what are they asking about? They're asking about the current. So every electron that goes into bit 1 must go on to bit 2. Okay. Let me go back one. No. Do they have the other one? There's one where it might ask you like, what is the electric field, or what is the current density in those? So those you have to be careful. It depends exactly what they're asking. So for this same question, the current density would not be the same, right? You'd have a greater current density in 1 than 2 because it's a narrower tube, right? And then your electric field would depend on your current density is your sigma times electric field. They have the same sigma. So greater J would mean a greater E. So you'd have a greater J and a greater E in section 1, but same I, because current is conserved. It's a tricky one. Well, it's not a tricky one. It's tricky to realize what they're asking. So this is one where you think about, what equation am I using? I was daydreaming, I'm not sure. L over A. Okay, so it's rho L over A. Oop. Is my internet crapping out again? Maybe. Came up with a little note. All right. I gotta think about it. So twice the length means twice the numerator. Twice the diameter means 4 times the area. So it's a 2/4. So I think it's B. Yeah. B. There's definitely a 2 in there. So this one is rho L over A. L doubles, A quadruples. It's tricky. 70. Wait, good question. Which one was it? That's a good question. Wait. No, it should be 1/2, right? Wire 2 has twice the length. Yeah. Yeah, it should be 1/2. No, it's 1/2 over 1, so it doesn't flip. Yeah. I had to go back and check. I'm like, wait. What do they mean by dissipate? So dissipate is one of those weird words that's sort of like, think of it like use. You might see use or draw or dissipate or consume. It's just sort of taking energy out of the system. That might be the best way to think about it. So it could be taking it out to run a light bulb, or it could just losing it in heat. But the energy has to go somewhere. And he says C. Skylar says C. You are correct. Wait. I misread. You are not correct. Should be B. So there's 3 different equations, I squared R, IV, and V squared over R. The trick is to pick one where one of those things is the same. You know they have the same delta V, so picking an equation that has delta V in it is your best bet. And you don't know I, so using R is a better idea. Mm-hmm. Does that one make sense? That one was... Ooh, I like this one. Right, battery current means the current that is leaving the battery. Total current in your system. You have a stream of people trying to leave a stadium. You open an additional stairwell for them to use to exit. Do they manage to exit more efficiently? Yes. Increases. Good. Mm-hmm. I think there was one of these on one of your tests. More people walking without dogs. Shouldn't be allowed. Okay, Skylar says D. What do y'all think? What do we mean by discharges? So this is one where the meaning of discharges is, loses charge. We have a definition for how long it takes to fully discharge a capacitor, which is 5 times the 5 tau, right? Where tau is the time constant. So whichever one has a greater time constant is going to have longer time to discharge. So whichever one is quickly is whichever has a smaller time constant. Time constant is R times C. So this one is 12. R times C, this one is 15. A is going to go faster. Yep. Tricky. So it doesn't matter the original charge because our definition has to do with the time constant, which has to do with what percent of the charge is remaining. So the actual value of the charge doesn't matter, it's just the percent, and that's the same regardless of how much the original charge is. Let's see. It is the smaller number. It discharges more quickly if tau is a shorter time. Closer does dominate. Right hand. Gotta use your right hand. Closer one dominates. You're into the screen. Yep. Ooh. Oh, that's the answer. Whoops. See, left hand. Gotta use your right hand. B, yes. Why? I did when I took my AP Physics test, I used my left hand for like half of it, and then I realized I had to go back and fix it. Because you hold your pen in your right hand, you just do with your left while you're doing it. Oh. So for this one, why is it B and not C? This is something that tripped up a lot of students on the previous test. And the reason it has to do with which way is your path length integral. So because your path is going around clockwise, counterclockwise, right? I1 is going with the path, so that one is positive. I2 is going against the path, so that one is negative. You have to look carefully at the little arrows, these little arrows, whoops, right here, that are almost illegible. So what you're looking for is if it was just I1, then mu naught I1 would get me a current or a field that goes in that direction. So I1 is going to be positive. That's tricky. Okay. And I'm going to post this for you if you want to do the ones we're skipping. Ooh, I like these. I don't believe there's any drawing graphs because we don't want to grade that. It's just no. Yeah. It's an electron. Gotta flip. So, correct answer is I get C. Let's see what the thing says. C! I tried. It's actually sad because that's one of my favorite things to do during a test is to watch y'all kind of. But with an online test, it's not as much fun. That's true. Oh my gosh, I can make like a Proctorio like supercut of students doing this. That would be pretty funny. I don't think I can download Proctorio videos anyway, so. Privacy. E is correct. Good job. The force is 0 because sine theta is 180. Sine of 180 is 0. Opposite directions, yeah. They got to be moving at odds with each other to get force for magnets. Okay. Ooh. Yeah, you're right next door trying to make it work. I'm like, So this is the same string. It's just a slightly different point in time. Uh-huh. The only thing that changed was the amplitude, and we know that the speed of a wave on a string has to do with the tension and the mass density. Wavelength, for pulse, it's kind of hard to say about wavelength. But you're correct. Yeah. No worries. I'm gonna step away for a second. Be right back. All right, I'm back. There's a 4. Okay, A, D, 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 D. Okay, so in order for it to travel half as fast, our tension has to go down to 1/4 its initial value. I think that sounds right to me. Yay! Good job. There's a 4, that's true. So that's actually a way to do this. You're like, okay, well, I know there's a 4, so that takes me either A or D. And then you're like, okay, if it's traveling faster, the tension must be lower, so it's got to be D. Yeah. Boop. Ooh, I don't think we even talked about this. It's not on the test. This is the fact that when an object enters a medium, the wavelength will decrease if the speed decreases, frequency stays the same. This one's C. Oop. Wait. There we go. There is one on the homework, yeah. So I made you read some section of the book, probably, for the first time in your life. Oh, that's good. How about this one? This is a do you understand how decibels work question. Any with a confident B? Anybody else want to agree, disagree? You got nothing. Okay. So remember the equation for decibels. B dB is 10 log I over I naught. So Annie, you're right. If this number increases by 10, goes up 10 times, that means the log increases by 1 because it is 1 power, which means I get decibels go up by 10. So 10 decibels is 10 times as loud. So the correct answer is B, 8 decibels. It's that 10 in the front of the equation. That's what gets you. So anyone is not correct. Yeah, true. Okay. All right. Oh, you're a flute player. 2 of my best friends are flute players. I'm not. I don't play anything. I have lots of instruments that I do not play. Ooh. The opposite of a flute is the tuba. I can see that. What's the opposite of a violin? I used to play violin. I'm salty because I snapped my E string doing the demo in class, and now I can't even pretend that I'm going to play it. I can see that. My best friend, when I used to play violin, played the cello. I also had a physics lab band. That was fun. Brown belt recorder player. Say triangle, yeah. Can you sing? Singing's a thing. saxophones and the most annoying people. No in between. Yeah. I don't know that many saxophonists. How are we doing with this question? I think you're right. What is this Twitch bot? What does the Twitch bot do? You're right, good job. It's been 2 hours, you can tell we're all kind of fading a little bit. Ooh, I like this. Is there somebody in the Twitch? Is that what you're trying to tell me? My phone closed and I haven't seen it. You can't scroll back in the chat, so I don't know what was going on here. Ooh, maybe it's still loaded in the background. Yeah. Yeah, that sounds like a bot. And banned. Oh, sorry. Like the actual question you're trying to work on. It is an open tube. You saw my Minecraft test. So last semester, my students for some reason really wanted me to play Minecraft. So we made this deal that if the average on their test 3 was above a 70, I would play Minecraft and stream it on Twitch for them. And they did. And then I just failed to get Minecraft. So I finally bought it. And now that none of them care anymore, I might stream. Okay. So open. You care. You would watch if I streamed Minecraft on Twitch. Grant's been making me like a server, but I have no idea what that even means. So. Yeah, it's B. Open means an anti-node at each end. Minecraft all hours of the day. Gonna need a more denoted WAM. Do you mean I need to download more RAM? Yes, so it is the number of nodes for an open tube. So B is the correct answer. Yeah. Okay. We'll do 2 more and then I'll say we're done. Unless any of you have any other questions. There's a lack of panic, which I think is a good thing. Yeah, sure. So there's an episode of Futurama where Fry decides he's gonna drink 300 cups of coffee. And the more coffee he drinks, the more like jittery and like, ugh. And then at 300, it's like zen. All becomes calm. And he can move in like super fast motion. I feel like that's the state y'all are in at this point. But yes, I will be open for emails. And I'm doing another session tomorrow morning if you have any more last minute questions. Okay. Point where the dot is. Okay, so remember that it's not about what they're doing at this instant, right? So at this instant, it's like it's not precisely a crest lined up with the trough, But we know that they are off by half a wavelength. And we know that they are out of phase. I feel like it should be constructive, but that's not right. That's true. I'm not sure about this one. Somewhere between. Oh, I see. It's because it's not... I don't like that one. You're supposed to look at this and see that they're off by a quarter wavelength. Yeah. I'm sorry. It should be C. I mislooked at it. This is off... It's actually 3/4 the wavelength. It's from here is 1, 2, 3/4. So they're not in sync or out of sync, and they're off by half a wavelength. So they're going to end up off by a quarter wavelength. I don't like that one. That one involves too much looking at the graph. Ooh, this one looks like it'll be better. I like this one better. I agree. They're green and blue, which is not great. Okay. They are in phase sources. It is a trough for one of them and a trough for the other. I think the answer is constructive. Gabrielle, do you see why? That it's yeah, a trough and a trough makes constructive, which is weird. It's like trough and a trough, cross and a cross. Right. Okie dokie. All right. It is 3:01. I'm gonna call it here unless anybody has any last minute questions. I will be checking my email. I will be doing another review session tomorrow. And if you run into problems during the exam, you can open the team and ask questions there. Don't worry, you got this. I've looked at the test. It's not terrifying. How's the homework go? Do you mean the grading for the homework? So I realize that this is very stressful for y'all and that I definitely should be doing the grading, but I have actually not been feeling well. Not to the point where I think I have COVID, but to the point where all I do is basically nap. So your homework will eventually be graded. I'm feeling better today, so I might actually get to grade some today. Yeah, it's probably a good thing that I don't leave my apartment. Will we have pity on the final? I will have pity because I think that... So here's the deal is that, like, we want to be merciful, but we also don't want you to move on to the next class and then fail because we let you go out of, physics when you didn't actually know this stuff. But I think we all tend to be somewhat merciful on the final. So, all right, I'll see you tomorrow morning. All of y'all have a lovely rest of your day. I will try to grade, but no promises. And have a great rest of your weekend. Bye. Oh, Katie. Stop. Oh. Oh, hi there. Oh, I'm sorry. Logan appeared right at the end, and I did not see it. um, I don't even remember which question that was about. I don't think the dot was on the antinodes. Sorry, Logan. I'm going to post this PowerPoint anyway. So I apologize if it was unclear. Also, it's lagging really hard. Okay. All right, bye.